Hi guys, I hope everybody's having a great day. We're going to learn about segment lengths when they intersect with a circle, whether it be chords that intersect or secants that intersect or tangents or a combination of them. So we are going to first just go through what the formulas are and then we're going to do some problems together. So first type that you guys are going to look at is if you have intersecting chords or secants, because those are technically the same thing. Secants would just be if your lines continued outside of the circle. So if you have these two where they're intersecting inside of the circle, your formula for this is you're going to take this length A times the length B. So the ones that create these same segments. So A times B, and that is going to be equal to C times D. So the segments that are connected are going to be matched up together. And then that's just your formula. A times B equals C times D. And then you guys can just manipulate and solve for whatever you are needing to solve for. Okay, the second type is when you have two secants that are intersecting outside of the circle. So these two are different because your intersection point in this one was in the middle. Intersection of these is outside of the circle. So that's how you know the difference between these two. Okay, so in this one, your formula is the part on the outside. So A times the entire secant that you have. So it's A times A plus B is going to equal, and then it's the same thing on the other side. C times, and then the whole thing C plus D. And then that's going to be your guys' formula you use. So again, it's the matching parts and then just remembering your formula. Okay, and then the third type is an intersecting secant and a tangent. So the BC is your secant because it intersects your circle twice, and the tangent is the one that has A because it only touches the circle once, and it only touches at that point right there, right? Okay, so the formula for this one is you have the A, the part that's all by itself becomes squared. So A squared is going to equal, and then this is set up just like it was in the other one. You have the B times, and then it's this whole length together, so B plus C. And so what you guys are going to do is you're going to just get different lengths of this, and then you're going to plug them in these formulas, and you're going to try to solve, okay? So for the notes, we're just going to go through the odds, and we're just going to find them together. Another important information is it just says, assume that segments that appear to be tangent are tangent. So we're just going to try to find these different values, okay? All right, let's start with number one. So this one is two secants or chords intersecting inside the circle. So we know if we're going to set up a formula, it's going to be x times 10. So 10x is going to equal, and then this goes in its own segment, 14 times 15. All right, and then easiest way to get x all by itself, because we're just trying to solve for x in this problem, is just to divide by 10. So you can just plug that in your calculator, 14 times 15 divided by 10, and you'll get x is 21. And that's going to be your final answer for this one. So this is if you have two chords or two secants that are intersecting inside of your circle because your intersection point's in here. Okay, so this one is same thing. You still have two chords that are intersecting inside, but we're now going to have to do a little bit more algebra. So we know that 27 goes with x plus 5. So one formula we can write is 27 times x plus 5. We know is going to equal, and then we know 24 and x plus 7 also go together. So 24 times x plus 7. All right, and then you guys just have to distribute and do some algebra and solve. So this becomes 27x, and then if I do 27 times 5, that becomes 135. Distribute over here, 24x, and then 24 times 7 is 168. Now we're just going to do our algebraic manipulations. And then we'll end up with 3x equals 33. So then if we divide both sides by 3, we'll get x is equal to 11. And then you guys are done. Now, if I asked you to find a certain segment length, you know you would just plug it back in and solve and find those lengths. Okay, so this one is two secants intersecting outside of the circle. So this is the formula where you have the outside part, so 8 times the entire segment together. So this is going to be 8 plus 19 is going to equal the small segment, so 9 times the big segment, which is just 9 plus x. Okay, and then you just have to do some algebra. So let's see, if I do 8 plus 19, that becomes 27. So this side is 27 times 8, which ends up being 216. And then over here, you do 9 times 9, which is 81. 9 times x is 9x. Subtract 81 from both sides. So you get 135 is equal to 9x. And then divide by 9, you'll get x is equal to 15. And then you guys are all done. Okay, this one is same thing, it's just a little bit more algebra. So you do 8 times the whole thing. So 8 times 8 plus 3x plus 4 is going to equal 7 times the whole thing. So 5x plus 2 plus 7. Okay, let's start by combining like terms. So I'm going to start by writing this as 8 times, I'm going to add the 8 and the 4 inside of there. So 3x plus 12 is equal to 7 times 5x plus, and then if I add the 7 and the 9, that's 9. Then your next step is going to be to distribute. So 24x equals, or sorry, 24x plus 96, 8 times 12, is 35x plus 63, 9 times 7. And then just do your algebra. So let's see, let's subtract 24x minus 63. And we get 33 equals 11x over here. So then if we divide by 11, we get x is 3. And then we're all done. Okay, a couple more. This one is now a tangent and a secant. So this is the one where you have the part all by itself. So that's the part that gets squared. So 24 squared equals, and then we set this one up the same way we just did the other ones. So this becomes 18 times 18 plus x. All right, so if we do 24 squared, 24 times 24, this side over here becomes 576. I'm going to distribute the 18 through here. So 18 times 18 is 324 plus 18x. Subtract 324. And we get 252 is equal to 18x. Divide by 18. So we get x is equal to 14. And then you guys are all done. So you just have to plug it in, do the math, find the side lengths. Okay, this one is similar, but it jumps up a bit. So this is similar to the one we just did. X is the one all by itself. X is the tangent. So it becomes x squared equals, and then this side over here is 27, the part outside, times the whole thing. So 27 plus 21. Okay, so this ultimately becomes x squared equals 27. And then if I add those inside parts in there, that becomes 48. So then 27 times 48 is 1,296. X squared equals that. So now to get x by itself, you just do the square root of both sides. So you're going to get x is equal to 36. And then you're all done. Okay, now we get into some big algebra skills in these next ones. So let's go ahead and knock these out. Okay, so we have intersecting chords on the inside of a circle. So we know these segments go together. So 12 times 10 is going to equal these two segments multiplied together. So x plus 6 times x minus 1. And then on the left side, we're just going to multiply. So this becomes 120 equals, now over here, you have to distribute. So x times x is x squared. This is negative x, positive 6x, negative 6. So we've got 120 equals x squared plus 5x minus 6. Now, as soon as you see the x squared and the x, you know you're going to have to factor. So what we need is we need this equation to equal 0. So I'm going to subtract 120 from both sides. So we'll get 0 equals x squared plus 5x minus 126. Now, what you guys have to do is you're looking for two numbers that multiply to be 126 and add to be 5. So the easiest way to go about doing this is just to take your calculator out and to just play around with some numbers. So let me get this calculator out here. Okay, so we need it to be 126. So I just type in 126 and I start dividing by numbers that I think would work. So like 8, maybe. And then if it comes out nice, then we know that that's a combination. So since that has a decimal, it doesn't work. So 126, let's do, I don't know, divided by 4. That also doesn't work. What about 126 divided by 9? Then you would just keep trying numbers, oops, until you get something that works. Okay, so you have 9 and 14. So we know that's a possibility. So let's see if that works with our numbers. So if I have 9 and 14, one of them has to be negative so that I multiply to negative 126, and then I need it to be a positive 5 when I add those together. So if I make the 9 negative, this works. So then I can factor this to be x plus 14 and x minus 9 equals 0. And then in order to solve for x, you just have to take each of those and set them equal to 0 and solve. So for the first one, you get x is equal to negative 14. And then the second one, you get x is 9. Now, the only thing you have to go back and check is if your segments are going to be positive or negative. So if I take this negative 14 and plug it in here, this little segment becomes negative 15, which doesn't make any sense whenever we're trying to do segment lengths. So lengths always have to be something that is positive. So that means that this 14 is not a correct answer, and the only answer that works is 9. So your segments have to end up being positive at the end of all of this. You just want to make sure that that checks out. Okay, last one, number 15. You have two segments, two secants intersecting outside of the circle. So let's do this red line first. So the part outside is 5.5. This becomes 5.5 times 5.5 plus 22.5, the whole segment. And then for the blue one, you have x times, and then the whole segment is x plus 15. Okay, so if we go about this, let's see, 22.5 plus 5.5, that becomes 28. And then if I do 28 times 5.5, that becomes 154. So left side is 154. And then over here, you're going to distribute x squared plus 15x. Okay, I see I have an x squared and x again, so I know I have to factor. So first step should be getting your equation equal to 0. So subtract 154 from both sides. Oops. Okay, so then it becomes 0 equals x squared plus 15x minus 154. And then remember to factor, you're looking for things that multiply to be negative 154 and add to be 15. So if we go back to our calculator over here, we're looking for 154. So let's take 154 and let's just start dividing. So maybe 4. Doesn't work. 154 divided by, I don't know, 7. Well, that one works. Okay, so 7 and 22. So if we do 7 and 22, we know one of them has to be negative. So when they multiply, we get negative 154. So if I make the negative and I add, I get the 15. So that works. So this becomes x minus 7 and x plus 22 equals 0. Because if you do, just multiply this back out. Negative 7 times 22 is negative 54. And then you'd have a positive 22x and a negative 7x, which would get you this 15x. Okay, so you set each one equal to 0, so you get x is 7 and x is negative 22. And then you just have to go back and make sure none of your segments become negative. So since this is just x, it can't be negative 22 because that doesn't make sense for length. So this won't be our answer. Our only answer would be x is 7. All right, I hope that makes a little bit of sense. It's relatively easy. You guys are just going to find the different segment lengths using these formulas up here. Make sure that you're paying attention to what problems I want you to do in this homework because it's not all of them. And as always, if you guys need anything, please reach out. And I hope you guys are having a great week. We're almost there. We got 2 weeks left. All right, bye guys.